the last thing in the patch.
Hi everyone, thanks for coming. I'd like to talk a little bit about how I made the Rust macro system more handsome, So the first thing I'd like to say about this is that if you're from the C or C++ world, macros aren't as scary as you may think they are. Well, maybe C macros are scary.
Okay. Okay.
Okay. You haven't missed anything. You haven't missed a very exciting title slide. So macros in C and C++ sort of have a bad reputation. But that's just because of the way that those macro systems were designed. I want to start by justifying the existence of a macro system at all. So in order to do that, I want you to assume that you hate code repetition. I hope that this is not hard to imagine. So you see code like this, where we're doing some letting and then some returning, and we're doing the same thing twice. And I hope that you have this sort of building feeling of rage that there's something wrong because we're taking we're indexing and then we're dividing by 7 times the index twice. So we need to fix this, and we can do this by writing a function. Let's call it adjust that does that thing that we were doing twice and call the function twice instead of doing the thing twice. This has a bunch of advantages. One thing it doesn't do is shorten the code, although it might if we do a lot of adjusting. But the more important advantages are that, well, let's suppose that you want to adjust differently. Now you only need to make the change in one place, and you don't have as much of a maintenance hassle. Or suppose that, more likely, there's some sort of representation change that you need to thread through a lot of different places. You're going to have an easier time of it if you just have to change the representations that adjust handles, rather than what happens at every single point in the program that would have gotten inlined if you hadn't written that as a function. It also makes the code easier to read because instead of writing out the steps of doing something, you've given it a name. And this name is something that you can attach documentation to. So now you can have a comment, presumably above adjust, that indicates why you're adjusting and under what circumstances one might adjust and what things one should assume and what things one shouldn't assume about adjusting. So eliminating code repetition by abstracting things out is awesome. We need to do this. So let's take a look at another example. This one is based on a true story. Let's imagine that you are, say, in a parser, and there are some circumstances under which you might receive a token which just has the answer that you want to return already. So you just want to return early in cases in which you've gotten the answer already. So you might match against a token, and it's some special thing that wraps an X. I should probably stop and explain the Rust match syntax for those of you who are not familiar with it. For one thing, it's no longer called alt. But basically, on the left-hand side of each of these arrows, we have a form that we're matching against. And on the right-hand side, we have something to do in response to that. So if if the token happens to be of the form special 1 of X, then we just take that X and return it. Underscore matches everything, so otherwise we do nothing. So that's great. But we discover that we need to do this at multiple points in the parser. So we have code repetition. This is bad. Okay, so let's fix this. We'll break out a function. So I've copied a version of one of the repetitions up as a template for making our function. And if you make a function, call it early return, takes an SP and a token, matches that token, sees if it's of the form SP of X, and returns X. Otherwise does nothing. This doesn't. I'm seeing facial expressions. This is good. In fact, this function is very wrong. You'll notice that I've left off the type of SP. The problem is not that there's a type problem. The problem is that SP isn't the value at all. It's a pattern that doesn't correspond to value. This function doesn't make sense. And furthermore, we're returning this early return. You can't early return from another function while inside a function. The early return is returning from the function that you just created in order to avoid this code repetition. This is completely wrong. But in some sense, it's sort of obvious what you wanted to do, right? There was some code repetition, and you came up with figured out what pattern that code repetition had, and you eliminated it. So the answer is that what you don't want is a function. What you want is a macro. So we have a macro that aside from having a slightly different syntax, does about the same thing, is written about the same way that we wrote that function. So now we define the early return function, the early return macro. It takes an SP, which is an ident, and a T, which is an expr, and then produces the code that you see on the right-hand side, dropping T and SP into their appropriate places. And this works because although SP at runtime doesn't have any sort of existence, at compile time, it's certainly an identifier, and macros happen at compile time. So it's possible to do an abstraction. It's possible to do an abstraction over these compile time bits of syntax. So you can write this early return macro, give it the identifier that you want it to unwrap, and it will return from the function that you actually intend to return from, because it hasn't wrapped an extra function which changes the meaning of return around everything. So this is the solution that I actually used to eliminate a particular instance of code repetition. So those of you who have been following my movements closely will notice that I was here last summer also creating a macro system for Rust. So what was wrong with that macro system? Well, this is what it would look like doing the same thing. Pound macro and defines early return and a pattern as a pattern, taking an SP and a T, and translating to that same right-hand side that we're pretty tired of seeing already. So it looks pretty similar. There are dollar signs missing. It's a little bit heavy on the square brackets. So what's wrong with this? One thing is that it's not quite as pretty. You may not be able to see it too much here, but in complicated macros, the square brackets get sort of out of control. Because in the old macro system, it was impossible for the macro to look inside and destructure any arguments that weren't square brackets. The previous syntax that we had, we were able to use like an arrow to separate the left-hand side from the right-hand side, and we were able to use like parentheses and commas and all of these things. And furthermore, we would have been able to choose custom ones, which would have helped make complicated macros more easy to discern the different parts of. Complicated macros in the 2011 Rust macro system were pretty much an indistinguishable mush of square brackets, and that wasn't great. There's another slight problem with the old macro system, and that's that this doesn't work. In particular, I mentioned that SP is an identifier and T is an expression. Well, the old macro system actually only allows you to put holes to abstract over positions do abstract over expression positions. So match T is fine. T can just be like cut out and you drop in the expression that you pulled out from there. But SP is an identifier, not an expression, and so you can't do that. So that was bad. Why did we do things that way? Well, sorry. So now you see on the screen the two problems that I just mentioned. Well, the problem is that the old macro system was based on the Rust AST. Now, Rust AST is a fairly conventional design, but what it's not is fairly conventional for a language that has powerful macros. So in language like Scheme, you have a very uniform AST, and it's possible to do these very abstract manipulations of the AST without regards to what role something is eventually going to play. But when you have a complicated AST whose structure is determined by the type system, you can't really play that game very easily. So one option would be to do a lot of coding, which would involve a lot of code repetition, which could be solved by a sufficiently powerful macro system. Unfortunately, the old macro system isn't sufficiently powerful for that. Furthermore, that wouldn't solve the first problem of the old macro system being ugly. So the solution was to, instead of abstracting over ASTs, abstract over sequences of tokens. So tokens nicely have a uniform representation. You can take a group of them and you can say, oh, let's repeat these tokens this sequence of times. I haven't talked about it, but our macro system allows you to. But our macro system has the capability to talk about macros that take arbitrarily linked sequences of things and expand to code that has arbitrarily linked sequences of things based on its input. So tokens give you a lot of flexibility for doing things like this. That's great, but perhaps they give you a little bit too much flexibility. For one thing, how do you just like take a sequence of tokens and find out where it ends? After all, when you're parsing a file that contains macros, you really want to be able to say, okay, the macro starts here, and it has an argument or arguments, and then it ends, and then I can continue parsing like normal. You don't want to say, okay, I see macro invocation, and the rest of the file is a pile of tokens. So we need to know where macros end. One thing you could do is you could like put them in quotes or something. This means that you would need to escape your quote character. So a macro that involves a macro invocation, which itself involves a macro invocation, would need to be doubly escaped. And when you go further down, it needs to be more and more escaped. This is completely unsustainable. You don't want to do this. So what we do is we decide that a macro invocation is a sequence of tokens surrounded by parentheses. And we'll say that you don't have to escape closed parentheses that you use as long as you have a nice open parenthesis that matches it. So basically, those macro invocations that we saw, although they looked fairly structured, and in fact, they were given a fair amount of structure by the macro definition, those macros were interpreted by the parser as just a sequence of tokens about which the only thing that it knew was that the delimiters in them were balanced. And that suffices. It's possible to find the end of macros, and it turns out that people don't really have a burning desire to write macros which take to come up with syntaxes which take unbalanced identifiers in them. There's just no point to doing that. So that was a slide with a lot of words. I think at this point you deserve a picture of a small, cute mammal acting in an anthropomorphic fashion.
Woo!
I'd like to close by saying I actually wrote some code to do this. I didn't just like sit around and think. So the code primarily the code that this entailed. I want to talk about implementation also, so that you get a sense for what macro system design is like, macro system implementation is like. These macros, because they define custom parsers for sequences of tokens, well, we needed to write a custom parser, something that could take an arbitrary grammar definition and then parse that sequence of tokens. So I had to write a parser. The other thing that we had to do was we had to, since these sequences of tokens, some of them needed to be parsed as Rust expressions. You notice that we were able to take a Rust expression as an argument in our macro system. We needed to be able to hook up these bags of tokens to the ordinary Rust parser, so that we could rely on the true Rust grammar to give us the interpretation of these sequences of tokens. So I needed to build a lexer that would lex these bags of tokens and turn them into a sequence of tokens for the parser to understand. The odd thing about it is that the lexer was actually harder to write than the parser. Go figure. So that's all I have to say. I'd like to thank the Rust team as a whole for their achievements in the field of awesomeness. I'd like to thank Eric in particular, who as a part of his work and also lately just recreationally has been testing out the Rust macro system. If you were paying close attention to his presentation, you would have noticed some telltale exclamation points that indicated that he was building syntax extensions. And I would also like to thank actually it's now 1,132 sticks of spearmint gum that I chewed over the course of building this macro system. That's all I have for you. If you have any questions, I'll be happy to. Yes?
How did you keep count?
The question is, how did I count the number of sticks of spearmint gum that I chewed? And the answer is that I stored the paper wrappers. I think originally I was intending to just okay, I'll keep the paper part and recycle it. And then eventually I didn't recycle it, and they just kept on stacking up. Since I chewed every single gum in those, I knew just multiply it by 14 and. Actually, the estimate is not precise. I'm pretty sure that before this I had thrown out some of the paper boxes, so it's an under approximation. Another question.
In your macro rules example, the syntax said, thing : expr and thing : ident.
Mm-hmm.
What are the other different classes of things that you can parameterize over? Keywords?
So keywords generally, if you want to come up with a key, if you want to like come up with new keywords, using identifiers will work for that. So I think that for most things for which you would be thinking keyword, ident would suffice. Actually, I'm not precisely sure what you mean by the suggestion keywords. We should maybe talk about that later. But to answer your question as a whole, what sorts of things can we abstract over? I believe that the current list includes identifiers and expressions you saw. There are patterns, statements, blocks, types, token trees. So you can, which is the right-hand side of a macro identification. So you can abstract over those specifically. And I believe items, and there may be a couple of others I'm forgetting.
How much effort is it going to be roughly to implement hygiene?
The question was, how much effort is it going to be to implement hygiene? Well, once we get the representation of identifiers changed throughout the compiler, so that they can, so that it's possible to extend them. Currently, identifiers in the compiler are represented as strings.
Yeah.
Once we do that, the implementation of hygiene will be self-contained. So it will just be a matter of hacking on the expander. For the most part, I don't believe that it's going to be too hard. I think that there are perhaps some subtleties that I haven't thought of yet, but the algorithm is relatively straightforward. It's a little bit mysterious why it does the things that it does, but the algorithm itself is fairly easy to implement. Under controlled circumstances, in the abstract, it's fairly easy to just like hack it up in a couple of days. In reality, it's probably it's probably harder than that. But hygiene itself is not so it doesn't put its tendrils into everything. It seems like it should be relatively self-contained, which will make it easier to implement. Any other questions? Yes.
So, if there is a type error or other compiler errors after the expansion,
Mm-hmm.
how would it, as a programmer, can I relate it back to the original macro error, or will it be with respect to the expanded code?
Good question. So the question was whether what happens if there is a type error or some other sort of compile error after on expanded code. How do you relate that back to the code that you actually wrote? So one of the few things I was able to reuse from last summer was an extension to the span system that we use to indicate the location of code problem. So when you get an error, it's reported in terms of some span of code. It says like from here to here, there was something that went wrong, and you get like a nice snippet. The Rust compiler displays a nice snippet of code and underlines the error for you, and it's awesome. So what I did was I extended that so that spans also have a stack of other spans indicating the expansion path. So when you get an error, of code that results from macro expansion, what you should get is the error in terms of the macro that at the very end expanded to the erroneous code. This isn't particularly useful. It shows you the general shape of the code that failed, but it's not going to tell you much about why it failed. And then it'll give you a backtrace indicating where each of those macro invocations came from, up to the original macro invocation that you called in straight ordinary code that kicked it all off. And in practice, I've discovered this seems to be reasonably useful for tracking down type errors. The theory of debugging code that was produced by macros is oddly not all that much discussed, despite the fact that schemers have to do this all the time. But this seems to suffice, especially in the case of Rust, in which we tend not to have really complicated whole program spanning macros. Rust macros tend to be a lot more self-contained than that. Any other questions?
What's the whiz-bangiest macro that you've built with this system?
The question is, what's the whiz-bangiest macros that I've built with this system? Well, I kind of want to say that it's actually the macros that Erica have written, because Eric's been doing the exciting macro writing, and I've mainly not been writing macros except as occasional tests. let's see. So last year I had this great example of a macro that of a Rust macro that is unfortunately obsolete because the feature has actually come into core Rust. But it would be a macro that the current macro system would be great for. It would have essentially provided the pipe feature for alt. Last summer, right, it wasn't possible to match multiple patterns to match multiple different patterns in a match statement and have them go to the same body. And it would be possible to write a Rust macro that would take these multiple patterns and the one body, and then expand into pattern body, pattern body, pattern body. And the neat thing is that the macro system, the macro definition system that we use, macro by example, makes it really easy to write this macro. It's just a matter of like straight writing. Like I want to take multiple patterns in a single block and expand them into pattern block pairs. Any other questions? Thank you all.
Cranmer from Toronto. Will be presenting for that.
Okay. Well. Okay. Okay, can people hear me? Can people see my screen?
We can hear you, but we can't see your screen.
But we can see your screen on the little monitor and on the medium-sized monitors, but not the big screen.
We're working on it.
Now we can't see it on the little one.
Okay. Okay, then, so are you going to try and work with the screen stuff? Or? I think we're going to back. We'll just wait for it. Okay. Yeah, let us know when you have things ready.
All right.
Cool. Now it's your turn to tell some jokes. We're not going to good jokes. You sure? Well, there was a time a few nights ago when Benjamin Smedberg was wondering if it would be faster to instead of using Python, to use Jython. And implement stuff in Java instead of using the Python implementation of PyMake. Yes. But if I ever heard someone suggest that it would be faster to use Java instead of slower. Yeah, I don't know about that one.
We briefly saw it. Now we're seeing it.
What was that?
We
briefly saw it.
We see your desktop, or at least a desktop. Could really
Yeah,
be anyone.
it's the one with jets on there.
It's mine.
You see lots of fighter jets.
We see fighter jets.
We see five.
Okay, you see my desktop.
Oh, that's what, yeah, that's what it looks like on your mobile.
Okay, so now you can see my fighter jets. Okay. So, hello, my name is Joshua Cranmer. I am currently working for Mozilla Toronto this year instead of Moutenot, which is why I'm talking to you remotely. The project I've been working on this past year is essentially working with code coverage in Firefox. So there are three main phases to my project. The first is getting the displays of code coverage to work properly, and also getting a tinderbox loaders to actually output code coverage results, which I finally got working last night. And also I've been working on trying to get JavaScript code coverage working. And finally, because all of our test suites are not necessarily indicative of how code really works, not indicative of how people actually use the browser, we're also looking at getting code coverage results from people when they actually run their browser. So first, let's talk about how we actually can view code coverage results. So for several years in the past, we have worked with a system called LCOV, which will take all of the code coverage results and will, let me zoom in a bit. So this is a list of all of the code coverage results from like all of the XPC shard tests as of last night. And as you can see, there are some places where we do really well, like accessibility is pretty good. I come down here a bit, and you see some bad places. And down here, we've got a very nice long block of no coverage. And go back to some decent coverage again. So the downside of this view is while you can look at this, while you can use this view, that you can actually go in and you can actually see for any given line of code how well it's, you can actually see in every single file how well it's covered. So you get a very nice view of actual individual lines of code. You can even see, for example, branch coverage here. This means that this branch is taken the truth. This branch has been taken once in the truth branch and none times in the false branch. Now, there are some downsides to this view. One of the things we can do is we can actually break out all of the results by test coverage. Except it turns out this is accessibility, which is largely only covered by one suite of tests. So there's only one file in here that isn't. But if I go into some more common code, like, this is a good one, networking code, we can see that HTTP code is used most of the time in contradistinction. Now, the other downside is that when I come and look at all this code, I see a giant block of data, and it gets really hard to get a good sense of how well or not well is all of Firefox covered. So what I've done is I've built a tree map, and I probably need to reload this page to actually see everything. So this is a nice little tree map, which shows, in this case, this is just the accessibility folder, how well everything is covered. The size of each box is proportional to how many lines of code there are, but I can also make it proportional to how many functions there are. Because sometimes you have code that has a lot of functions, but each function is really tiny, or other times you have 10,000 line functions. This is more common in some of our generated code bindings. You can also, each color is indicative of how well covered the code is. So for example, Xform's code is not terribly well covered, but table accessibility seems to be well covered. You can also do, instead of line coverage, you can focus on function coverage or branch coverage. Some code, it turns out, doesn't actually have any branches, interestingly enough. You can also zoom in on a subdirectory, and you can zoom out. So if I'm going to come out and I'm going to show you the code coverage of all of Firefox, this will take a while. Now you can get, in a single picture, a very good idea of how well covered, or in some cases how not well covered, Firefox is. For example, you can clearly see right now we've got two test suites which are pretty much completely non-covered. This is the graphics Skia code and the WebRTC code, which I've been told have very good coverage, just not actually being run by the test suites. Now, as you may know, or you may not know, Firefox has a lot of test suites. This is basically a graph of, this is a list of every single test that Firefox runs. We have several different platforms: Linux, Android, Bootgecko now, OS X. And for some of these platforms, you have even more stuff, like you do distinguish between OS X 10.5, 10.6, 10.7, 10.8, or Windows, Windows 64, XP7, etc., etc., etc. And for each of these platforms, we also have several different tests. We've got compiled code tests. We have got several suites of low-key tests. We have ref tests, which fall into the category of crash tests. JS ref tests, which test our JSON engine more than just regular old ref tests. And we also have PEP tests, which control the browser, and XPC shell tests, which are main unit tests. So if you're a new contributor and you want to know where does this kind of code coverage come from, if you just see a line of code, you have no idea which test suite to run, unless you really know the code. And even some experienced contributors still don't exactly know how to run all the test suites, or if the test suites are actually testing their code. For example, I didn't know until last night that all the accessibility tests were in a single test suite. And I only discovered that when my scripts failed and didn't actually include that test suite, and said that all of accessibility was uncovered. So what I have is you can also view how well the coverage is done by specific test suites. So for example, if I select first tests, and we wait, you can now go back to accessibility and see that all the accessibility is uncovered. And if we go back to our main top level directory, you can see several changes after the code finishes loading. For example, a lot of the graphics code becomes a lot less well tested, and a lot of other various features. Some of this is going to be places code. We've got some WebGL rendering stuff which is not well tested, etc., etc., etc. So in addition to this tree map view, I've also done work on getting JavaScript code coverage. This is actually not from Firefox code, this is from Mozilla, this is from Thunderbird's code base. But what we have here is this is the actual JavaScript code. You can clearly see this is JavaScript, not C++. And we can actually tell you how much lines of code are actually being covered. And the way this works is it turns out that Brian Hackett, over the past year, implemented a feature in the JavaScript engine which actually reports out, which lets you see all the counts of every single JavaScript opcode, how many times every single opcode has been executed. So by looking at all of the counts of every single source file in the code base, of which there is a grand total of a lot more,
That's fantastic.
as if I were, this is probably going to blow up my browser because I haven't done this in months, and it's going to show up several. Yes, it's already not responding. But what happens is, oops, I didn't want to stop that script. Sorry. Rule of thumb, demos always fail on you at the last minute.
You need more tabs open.
No, I don't. Yeah, unfortunately, this is an older drop of the code base before I made things not use so much JavaScript, which means I'm going to get about 3 of these dialogues before it finally shuts up and actually shows you the results. As a template which is doing web design in the future, use CSS transitions instead of implementing animation in JavaScript yourself. It makes your life so much easier. Well, maybe not easier, but at least it stops your browser from doing this. That's the last one. Anyways, while we wait for this to finish loading, I can show you some more stuff. So the last piece of the puzzle I was discussing was being able to actually show dynamic code coverage. So what I've done is I've taken a build of Firefox and I've hacked the compiler so that at every single function entry, we stop the program, we record in the table that we run the function, and then we patch the code to no longer use this on-entry function hook, because if we kept doing every single entry function hook, the browser would slow down to a crawl. So here I've got another example of another browser. This is in Linux. And this is one of the things that I've actually done with the instrumentation enabled. And as you can see, the browser is still very snappy and I can do all sorts of stuff, at least as well as I was doing before. I think the fact that I'm also writing script in the other browser is a couple of things right now. So now that we've collected all the data in one instance of the browser, what I do is I use telemetry, and I will actually, when telemetry sends out this data ping, it will also include as a list the giant table of everything that's been run by the network code coverage. So what I can do is I have some scripts which can take the results of these hit tables and wait for the slow script dialog to stop. I can just come in here and hopefully remember the URL. And I can view the results. Unfortunately, these are not so prettily easily displayed, but I can show you, for example, all the functions that have been hit by my current browser by just browsing around. So, for example, if I was to look up some accessibility code, again, you can't see this probably. So you look at accessibility code, unfortunately you zoom in, it changes your position on you. So you can see, for example, if I just start going through a lot of accessibility code down here, I'm not hitting any accessibility because I'm not using the browser for accessibility. On the other hand, if I start going into some more JavaScript code, assume I can hit JavaScript code nice and well. This is also IPC code, which is not really run over, at least not locally. Actually, let me just move to SVG, because some of the SVG code I know I'm using. So you can see here that I'm hitting some of this vector-image code for SVG instead. So if I take all this data and once we actually get this pushed out to some releases stuff, like perhaps on the profiling branch, we can actually start recording results from the giant user base at large to get an idea of what features people are actually using in the browser. So, are there any questions?
I have one.
Yes?
Is this going live? Like, can I use this?
Which disk are you talking about?
The visualization of food coverage.
Yes, you can actually do it right now. If you go to people.mozilla.org/tilde, let me see if I can. I'm not pinging those things open. Oh, that's good. Give me a second. Can people see this? Probably not. I bet they can zoom in a bit more. Yeah, that's as large as that we can go. Let me gooey it is.
You can use the Linux magnifier.
Oh,
What do you do?
Yeah. Okay. What about Notepad? And then I can hang on me.
Now we're gonna DNS server.
It's Mozilla site, not mine.
Okay. Nice.
So this is the URL for the actual. Can you see that?
Yep.
Okay. This is the URL for the actual visualization. If you want the raw data, don't put the coverage.html and on the end of it. You can actually see the same visualization that I see once my code stops doing the slow script dialogues. Any other questions? I see everyone's run away apparently. At least
I have a question. Can you hear me?
Yes?
How easy would it be to retarget this to other sources of data? Like how generic is the front end?
Okay, so what happens is the front end is anytime you can bring out outcome data, so anytime you can use G-code results effectively, you just have to run some scripts. I have some this code's on GitHub. Hopefully I have the GitHub site. I don't have it memorized, unfortunately, but it should be something like this. If not, just look for Jake Cranmer on GitHub, and if you see the Mozilla coverage, that's got all of my tools. Some of the latest changes I haven't yet uploaded, but there's a script in there called makeui.py, and what that does is when you pass in the results from, so after you run outcome on all the Gcode data, it spits out a .info file, and if you feed that into the scripts I have, you can generate a .json file, which you can then plug into the web UI to actually get all these features. And this should work across all browsers, except it only tests in Firefox, so I have no idea if it works in Chrome or not.
Fine.
Any other questions? Yeah, let me show you the GitHub link now. So here's one of the code. So for example, here's the code I was talking about that actually makes the web UI. I am planning on putting this in the blog post. I just haven't had time yet. So you're the first to hear about it. Cool.
I think across the
Marshall?
All standard stuff. Okay. That's for us, is getting G-code support.
Is there a way to make this not a mirrored display?
On the top bar up there?
Yeah.
Well, I can't see it because of that.
The resolution's fine. System preferences. Just plug it in.
Size to guess. Instead of putting something that says showing you.
Displays.
Yeah, under arrangements, you should change it from here to
Okay.
just right.
Perfect. Thank you.
Work especially about making the debug accurate.
Do you need to wait for any of your team members to come or anything?
I think most of my team is here. Yeah, I think everyone's here. All right, so are we ready? Okay, I'm Marshall Moutenot. I'm an intern on the security engineering team, and one of the things I worked on this summer is low rights sandboxed Firefox, and I worked with Ian Melvin primarily. So what is sandboxing? You guys have all probably heard the term around. It's like as popular as anything security related can be. It's featured prominently at every single security conference, and you've probably seen things like the protected Adobe Reader, and you've heard about Chrome being sandboxed. So I think it's going to be present in almost every single web-facing application, especially browsers. So sandboxes don't sound especially strong. You can like walk over and crush a sandcastle, no problem. So think about it more as like Fort Knoxing. You are turning a browser into something that can't be broken out of or into. So what they do is they help prevent malicious, untrusted code from writing, installing, accessing resources that they shouldn't have access to. And it does that by separating components from each other. So it takes something like the render and separates it from some other component, so that if one is exploited, the other one isn't affected. So each component is given only the minimum number of permissions it needs to be able to complete the task or function that it's meant to complete. So it doesn't prevent exploitation at all. If there's a vulnerability in the renderer, it's still going to be present. What happens is sandboxing focuses on post-exploit mitigation, which is to say once an attacker breaks in and successfully exploits the browser, the sandbox prevents the attacker from gaining any control over the operating system. So we look at a component and we say, should this access the registry? Does the renderer need to be able to download a file and then launch it as an executable? Probably not. It's probably not a good idea. So we want to figure out which privileges which components need. So we use the Chromium Sandbox, which is a user mode only sandbox, which means that it doesn't need any special kernel mode drivers, which is something that other implementations of sandboxes need. Users don't need to be administrators in order to have the sandbox operate correctly. So it's perfect. It's unobtrusive. It's perfect for something like Firefox. And we focused initially on Windows because that's where our largest insecure user base is. It would be interesting in the future to look at, like, OS X now has all these policies for sandboxing, so it would be interesting to look at that in the future. But for now, just Windows. And for those of you who don't know, there used to be a project called E10S, or electrolysis, which was aimed at separating content in Chrome. And they faced a lot of the same problems that we're facing. So especially related to add-ons, which I'll get to later, we're going to have to figure out these problems, which may or may not be possible. So we're looking into that. So sandboxing operates at what's called a process level granularity. So to be sandboxed, each component needs to live in its own process. And a minimal sandbox has two processes. One that's privileged, called the broker, and any number of targets, which are restricted. So the broker is the conduit for all sandbox target processes, all the restricted processes, to access resources that are otherwise restricted through their policy. So they do so through an API to the broker. And the broker enforces a policy that's built from a series of rules which dictate which targets can access which resources. So like I was saying earlier about identifying which components need which resources, that all lives in the broker's policy. So here's a nice illustration. We have the broker with its policy and two target restricted processes. So the most interesting problem is add-ons. So if an add-on tries to access a resource, it's intercepted, that request is intercepted and sent along the IPC to the broker's API. And the broker compares that to the policy and says, is that allowed? Can that target access this resource? And for add-ons, it's really hard for us to say, well, what resources does this given add-on need to access? So what happens is if it's not in the policy, the broker just returns a failure and the target will fail when it tries to access that resource. So add-ons are the biggest challenge. And the reason for that is because Firefox add-ons are the most powerful add-ons of any browser. They have complete free reign, and if you install an add-on in Firefox, it's hard to tell what is Firefox and what is the add-on. Other browsers are able to implement sandboxes much easier because they have APIs, and their add-ons can only access resources through these APIs. So another interesting statistic, and this is really rough, but somewhere around 60% of users have at least one add-on. So even if we can't find a perfect solution for add-ons, we could even ship a sandboxed Firefox to users without add-ons to at least secure that user base. And it would be significant. It's a significant percentage. So I spent a lot of my time researching patterns of resource usage in add-ons, and I found a lot of interesting patterns. Some examples are that most add-ons that access files do so through a file picker, which is great, because we could just put that file picker in the broker, and the worst an exploit could do if it compromises a process is open up the file picker, and hopefully users are smart enough to like click cancel pop-ups or if they're being prompted randomly to pick files. And then there are a few components that have random DLLs, and really hard to tell what they do, because they could just start downloading things and executing things, and so those aren't great for sandboxing. So we came up with a bunch of possible solutions, and my personal favorite is that we require a manifest with each add-on that states each resource that an add-on has to access. It would be similar to what you see in like the Android App Store, but way more granular. So it's like, I have to access this executable, this file path. There are definitely pros and cons. The pro is that it could be easier for reviewing if an add-on can only access things that it explicitly states and fails otherwise. And for the same reason, it could be good for user transparency. Cons, definitely altering the add-on process, and existing add-ons would all have to be updated with this manifest to work in a sandbox. One way to combat this is that you could disable sandboxing if a user decides to install a certain add-on. So you could say, oh, you're about to install this add-on that's going to lower the security of the browser, but that isn't ideal either. So, I mean, this is an open-ended problem, and I wanted to keep this high level. So I wanted you guys, if you have any suggestions, to just discuss this now. I'm just going to like open up this problem to discussion. So yeah, thank you.
Can you automatically generate meta?
We looked at statically analyzing add-ons to try to figure out what resources they use. But currently, a lot of the JavaScript analyzers we have aren't able to follow all the API calls that the add-ons make to get handles on those resources. So currently, it seemed really difficult to do that. But it looks like people are trying to make things that can statically analyze add-ons to that extent. So I mean, that would be ideal.
How did you gather your data about what add-ons do?
I wrote a bunch of scripts. I downloaded a ton of add-ons from the AMO because the add-ons MXR wasn't working. And I just wrote a lot of Python scripts to use regular expressions. I went through the top like 10 manually just to get a feel for, because I'd never really looked at add-ons before. And then I talked to a ton of add-ons people.
So couldn't you reuse those scripts to come up with some kind of sandbox for now of what, like, you know, a conservative one probably?
Yeah, I mean, potentially. The problem is they're very rough because they're just, I mean, they're usually pattern matching. So it's usually, does this one have like something that looks like it's trying to get access to a file?
Right.
And it's hard to tell, especially because a lot of the top ones, not in AMO, are installed automatically, like the Skype, the .NET helper, like all these random junk add-ons that have binary components. And it's like, with DLLs, it's like really hard to figure out what to do. So, I mean, that's definitely true. We could do like some rough estimation just to get some support, but
seems like the big problem is the existing add-on. In other words, people probably could do this going forward, but you want to get all the ones.
Yeah, exactly.
So you said that like this is your favorite solution, but are there some other sort of standard solutions besides? Because like the Android App Store has a manifest, I assume the iOS has a similar thing. Is there another like competing solution to making a manifest?
Not that I know of. I mean, this is my favorite, and also like the one that makes like nearly any sense, you know, to implement. I'm trying to. Ian, I know we mentioned a few other ones. I can't.
We talked about, like you said, disabling stuff, disabling sandboxing, warning the user when they're installing out on the big sandboxing.
Right. So we could do something like you mentioned, where we do some rough estimation and support those, and then just say, hey, listen, you're going to install this like Skype helper, and that's going to lower Firefox's privileges. So
Shipping a default whitelist that would allow those common add-ons to work.
Right.
Reduces the security, but
When you said that 60% of the users have at least one add-on, do we know which ones they are, and do we know, is it like 90% of those add-ons are Skype or something?
Well, the top 3 are the Skype.net, like the 3 that are really high up are, I think, have binary components, and then unfortunately only two in the top 100 are Jetpack. So if we had lots of Jetpack, that'd be great because they're going through this API. So yeah, I've been gathering the statistics on that. I don't remember them off the top of my head, but
So with binary components, you just have no security. You can't sandbox it, or
it's really hard to tell with a DLL like what it's going to access.
I mean, if you run it in a separate process, you can tell, but
No,
then it doesn't work at all, I guess.
Yeah, I mean, no, that's true. It is possible that I know that like Chrome has a separate sandbox for its add-ons, so it could be possible to like cater one towards that to specifically allow those things, but yeah.
Did you work at all with the Open Web Apps team as far as like any kind of sandboxing for like the various like permission levels of Open Web Apps that they have?
I haven't. I don't even know what that is actually.
Okay.
But I'll talk to you after, maybe?
Sure.
Okay, cool. Anyone else? Cool, thank you.
I want to try something radical.
Joseph, would you like to wait until
Is there no one else who's meant to?
No, everyone's been going kind of short.
Oh, I can go now. No problem.
Do we need to wait for anybody?
Sorry?
Do we need to wait for anybody to come?
Someone from the team was going to come, but she's downstairs. So no.
Okay. I'm sneaking really fast, or give me your...
I'll ping her, yeah.
Okay.
It works for libraries to do pure computation.
Yeah, sure. Yes. Let's see, maybe all external libraries for sure.
Wait. That's one solution. It's also a Linux solution.
Yeah, this one. Well, you could create a sample policy. I'm sure you can.
She's just downstairs.
The Chromium Sandbox. Super simple, but you have to It's like the mode for Sandbox.
Yeah. No, but then we also, for the Rust parts, the parts that are pure Rust, we do lightweight static capabilities. And then, like, that's so much simpler than this. But I looked at this stuff. It's insanely complicated. On Linux and stuff. And it involves monkey touching protocols. Like at the assembly level, decompiling the assembly level. Just try it. I don't like it. I don't like the Chromium Sandbox. Like, it's so better is better than
I don't know if you're disassembling and patching calls, that's there.
I know, it's ridiculous. I just object. I object to this. We'll do it if we have to, but seriously, like, I want to try something else before we do that. You know, like.
I'm guessing your laptop is not named unknown.
Hey.
There we go.
Magic.
Architect it as if
This is a sneak preview of my phone.
and then hope that in 5 years sandboxing technology catches up. And there are some better solutions out there.
I don't know, I think that we should adding some IPC stuff, some simple pipe-like IPC stuff to Rust, and then try to put our industry cover in that. We can do that fairly simple.
Yeah.
It's ready when you are.
And then we.
Okay.
Not a
Hello everyone, my name is Joseph Kelly. I'm a statistics PhD student and I've been here for the summer working with the metrics team. So for today I'm going to be talking about applied statistics at Mozilla, modeling active daily installations. I originally was going to talk about a couple of topics, including the work I've been doing with regards to performance testing, but when I was getting all my slides together I soon realized that I wouldn't be able to cover more than one topic. So for today, we'll be modeling ADIs. So a little bit of background. I'm sure some of you may already know this already, but once a day, Firefox does a scheduled check to see if any harmful add-ons or plugins have been installed. This sends information back to Mozilla, such as Firefox version, operating system, etc. And active daily installations, or ADIs, is defined as the sum of these instances on a particular day. Okay? But note that ADI is not the same as active daily users, right? So for an example, a user could have multiple Firefox installations running on multiple machines. You can also disable this feature so you won't send anything back to Mozilla as well. It's not the same as active daily users, but it does give some sort of indication of how much usage there is of Firefox in the wild. So it is something of interest. So this is what we're looking at. This is the ADI count in tens of millions, ranging from July 2008 to almost the end of June 2012. And this is what we're interested in modeling. You can kind of see here that there does seem to be some structure, right? In fact, over this time period, there does seem to be some sort of positive trend. It does seem to be growing. So one of our goals is, in fact, to try and model this guy. And in particular, we have two goals. We want to smooth the series to get a better idea of how ADA changes over time. And we want to produce a weekly report comparing observed ADIs for that week to those predicted from the model. Right, so this is going to give us some indication of how things are going. If we have a forecast for next week and we observe that our ADI counts were low, perhaps there's some reason for this and we can go and further investigate. All on the same page? Excellent. So we want to model this. We want to model this guy, right? So the first approach I was thinking was assuming a dynamic linear model, okay? And this is a constant dynamic linear model. And what this basically assumes is that the response, which is the YT, right, is the actual observed ADI count for at time t. So that's what we get to observe. And we then assume that this observation is actually equal to some trend value plus some random noise, right? So the mu t's here is the actual trend that we're interested in. But we don't get to observe the trend. We get to observe the yt's, the actual observed ADIs, right? So the yt's are some random fluctuations around the trend. We saw earlier that the trend changes over time, so you need to put some sort of time structure built in here, right? So this is the second line of the equation. We basically assume that the trend at time t is equal to what it was yesterday plus some white noise, right? It follows a Gaussian distribution. The white noise here is this omega t, right? It has a Gaussian distribution, mean zero, and some variance. So all we're really assuming here is that the trend is a random walk. It's a very simple dynamic linear model. The key thing to take home, we get to observe the yt, but what we're actually interested in is the set of mu t's, the trend. Okay, so we need to infer what they are. So we could just go ahead and fit that model to what we have here, but upon a closer look, if we condition on a variable called days of the week, we'll actually notice that there's some structure here. Okay, so this is the same plot, ADI count over time, but now we're just color coding the days of the week. So here we can actually see that there does seem to be some trend, right? But that each day of week seems to be some offset from this trend value. So the model we assumed earlier, the constant linear model, wouldn't really pick this up, right? So we need to somehow incorporate the fact that different days of the week has a different offset away from the trend. And so this is going to lead us to the next step of our model, which is a dynamic linear regression, which allows us to include covariates. Very similar setup to what we had earlier.
Question?
Sure.
What's a covariate?
A covariate? It's something other than the response that you observe at some point in time, which you may think which may give you some information about that response. So in terms of ADI counts, here we know knowing what day of the week it is actually helps us predict what the ADI would be, because we know that ADI changes according to day of the week. Right? So something other than the variable of interest, which may provide some information about the variable of interest. That's a covariate. So the model that we're assuming here, very similar, although this time we're actually assuming that the response, or our ADI count, is some random fluctuation around some line, right? Some regression line, right? Which is denoted by this guy here. Similar to the setup before, we then assume that the intercept and coefficient for our regression line follows a random walk as well, right? So that the intercept and coefficient at time t is just the intercept and coefficient at t minus 1 plus some white noise. Okay? Again, the same thing's happening. We get to observe the yt, but we're interested in the trend, so what we're actually interested in is the alphas and the betas. Please let me know if there's any questions or anything is unclear. And the reason why this is a neat little idea is that if the solid black line here is the true trend, and the x-axis is say, some covariate that we have, and we can see that it changes with respect to the covariate. In any local region, in any small in any small region, like region 1, a line will fit the curve very well. Similarly, region 2, a line will fit the curve very well. Okay? But this dotted line and this dotted line have different intercepts and different slopes. So as we progress through time, we need to have the intercept and slope changing in order to fit a trend line which is sort of curvy and not necessarily just a straight line. And so basically, this is the setup that we have. This is the setup of a dynamic linear regression. And this is what we're going to do. Well, this is what we did do. So we actually assumed this a dynamic linear regression where our covariates, before I just had one covariate, but our covariates here is a set of indicators indicating which day of the week you're in. Okay? And it may be a little bit difficult to see. I hope the colors come out okay. But the black lines, which may be hard to see, is actually the observed ADI counts. The red lines are the one step ahead forecasts. Right? So at time t, the red value at time t is actually using only information available to it at t minus 1. So one step ahead forecasts. Anurag?
Can you predict what will happen at the end of 2013?
I will do a forecast. Yes, exactly.
Perfect.
This series goes to 2000. That's a very good point. This series goes. The end of this series is 2012 June 23rd. I'll talk about the limitations of the model and how far ahead it may be reasonable to predict.
Okay.
The model I'm assuming, not to 2013.
Okay. And how's the split by geo?
Sorry?
Have you done the split by geo?
No. This is total ADI count, so aggregating all of the different countries or different geographical regions.
Okay.
There's no reason, if you're particularly interested in a particular geographical reason, there's no reason why you couldn't assume a similar model for that region. And maybe even do some more sophisticated things by borrowing information from region to region.
Okay. I'll ping you later then.
Yes, definitely. And the blue line here is actually the smooth line. So this is the mean trend. This is what we're actually interested in. Okay, and maybe this is what we should be paying attention to. Right? This gives us an indication of how ADIs change over time. We're not interested in all this fluctuation, the day-to-day noise. We're interested in the blue trend. Okay? So that's goal 1, right? We smoothed it. Goal 2 is this forecast what Anurag was talking about. So the idea is that we want to produce a weekly report where we have observed ADI values as well as their forecasted values. So this is the outer sample forecast. Before the end of the series was, the 23rd, and now this is from the 24th to the 30th. So what we're doing here is the black dots are the observed ADI counts. The red dots here, and let me know if this plot works or not, because it's something that I'm playing with, is you can simulate from the model and predict values, ADI values in the future, right? But there's some variability according to these values. So this is meant to represent the distribution of predicted values at that point in time. So the less red it is, the less dense the distribution is. Okay? So basically, if a black dot falls outside or falls towards the tail of the red line, it's kind of saying that this may be unusual.
And how many standard deviations is that red blur? Or how large is it?
I think it's based on 1,000 predictions overplotted on top of each other. So, indeed, you can say, like, you can get the 2.5% or 97.5 percentile interval as well from this to say, okay, it lies outside of this prediction interval. Do you think that's maybe a more intuitive thing to do? This is like a graph I'm playing with. So
Yeah, I'm just trying to get a sense of what confidence interval that would be.
yeah. Yeah, I think I agree with you. Yeah. So basically, if it lies in a period of low, if the black dot lies in a period where there's low transparency, where it's not as red, that's an unlikely observation. I agree. Perhaps I should have put in some bars saying this is the actual interval, which may be more useful. Maybe I'll do that next time. Good point. But the thing with if you just have an interval, it doesn't actually show you the density within the interval and how the distribution looks. That's why I was trying to play with something like this. But maybe we can do both, in fact. Very good point. The blue line here is the predicted mean trend that we had from earlier. And so the idea is that for a particular week, if you observe ADI count for a particular day, say that's way off, maybe that may be worth investigating. Maybe it's just a holiday and we're not that worried about it, right? But maybe it's more indicative of something else which is going on. Right? So this is just kind of a way to keep track of how ADIs are going and make sure that we're still on track, basically. Christina.
Would you have used the box plot instead of doing the red distribution? It's a question. From my understanding.
Yes, you could very much do that.
Can you repeat the question?
Oh, sorry. Could you use a box plot instead of these red dots?
I like the red dots.
You like the red dots?
No, I actually think I'm the non-technical person in the room. But I look at that and I look at, Monday and Tuesday, and those guys are clearly higher than what we would have predicted, right? They're out there at the edges.
Yes.
And I look at Wednesday and Thursday, and they seem to be much more in line with what most of the predictions would have put it.
Yes.
And the visualization to me, being sort of not technical, is that I can look at one of those and say if that dot is way high or way low on one of those bars, away from the red dense areas, that's potentially abnormal and worth investigating. So if I saw that black dot on Monday sitting down, outside of the lightest pink at the bottom there, I'd worry. I'd like, did something happen? Did our measuring go askew? Did we lose a hunk of data in the system? Did people go on vacation in France? And for me, that as just purely a visual person, this visual description works really well. I have no idea about the science or any of that part. I'm not a statistician, but I can look at that and very quickly get an idea which one of those would bother me.
Okay.
Now it turns out that when they're on the upper side there, it doesn't bother me too much.
Of course. Okay, great. Yes, that's what I was going for. The fact that you had this density allows you to see the distribution. A box plot gives you some sense, but not. Also give you a whole picture of the distribution, and you have to know how to read a box plot.
Right, and the distribution here isn't even. It's a little bit lumpy.
Yeah.
And so I can also take away from that sort of, some of those are going to be sort of an even shade across a larger piece of it, or have a couple of dark, dense areas in them, where you would have predicted. So there's even more information that I can very quickly absorb visually.
Yes.
By just seeing those density differences.
Yes. Yes. Yes, exactly. That's a good point. It basically allows you to see the distribution. Okie dokie. I think that's pretty much it. I think I have a thank you. Oh no, I have some extensions. Not thank you yet. So the purpose of this model, I have to go back to Anurag's question too. So the purpose of this model was to smooth the series and obtain 1 week ahead predictions. And the model does very well for this purpose, which is what it was designed for. If you do want to do something like predict more than 1 week and predict months into the future, this is not going to cut it. But it may be possible to obtain accurate forecasts by doing a couple of things. So one is that you need to actually model the structure a little bit more than what we're doing. So you need to include some seasonal factors, maybe those related to calendar time, such as months and holidays. You can include further covariates, maybe Firefox download data. If lots of people are downloading Firefox, perhaps maybe that gives us some predictive power of ADI count, and maybe other things. So maybe Google Trend data, like how many Firefox searches were there this week, this kind of thing. And the model we
also could factor in things like proximity to a release date, because we know that around Firefox releases we see, little spikes or big spikes in downloads and little spikes in usage, and then oftentimes a new baseline established for what usage is going to look like. Releases have this weird impact, but that is pretty easily modeled by looking at our history. It's very consistent what happens when we do a release.
Right. Yeah, very good point. Yeah. So, and the neat thing is that because of the way we set it up is that we can very easily include these new factors into our model, and it shouldn't be too much of a problem.
Given timed releases, they're like holidays. You can predict them.
Yes. Exactly.
Joe.
Sorry.
I was curious. Was there anything in the data that lent itself to you choosing to use a dynamic linear model? Like, could you have chosen did you evaluate other models? Like, for instance, could you have done like an additive or multiplicative decomposition or like a Riemann model kind of thing? Or?
I did do a Riemann model as well.
That wasn't as accurate as that?
It performed in much the same way.
And what was the measurement of accuracy for the model? Is it in standard deviations?
You mean the?
Like, how do you assess?
How do you assess how good it is? Right. There's numerous things you can look at. You can look at the fit. How well does it fit the data? You can also, and how I like to evaluate models is have a validation. So you have an outer sample set, which you don't include in your model, and then use that to predict. Right. So we could do one step ahead predictions using only the weeks previous to that week and see how well it performs. And you can use that to assess how good your model is. Because you have like a training set, you train your model on some data, and you have a test set where you can test the model, and then you can make modeling assumptions based on how well it performs in the outer sample set.
So how well did your model perform for thus far for 2012?
It's doing well. It's good. Yeah, this is the best one.
What's the units of measurement on that?
The English word well.
Yeah, you can do many things. You can look at for example, how close your forecast value is to the observed value, and calculate that difference, and which is the residuals, right? And you can look at the sums of the squares of these residuals and compare that to other models, right? So this is how some of the modeling steps are done. So basically, how far away were your predictions from the forecast values? You calculate the difference, you square them up, sum them. You can compare. You can use this value and compare across models. Choose the one which has the lowest. Choose the model which has the lowest. Somewhat similar to R-squared. Yeah, great question. That's a very important point. That is how to choose models when you have multiple ones. I think this is the thank you slide. Thank you. My time here has just been awesome. Big thanks to the metrics team. They've been amazing. And the rest of the Mozilla community. It's been an awesome summer. So thank you very much. And if there's any questions, please come up. We can have a talk. Also, if you're interested in the performance testing stuff I've been doing, definitely ping me as well. Cheers.